Students, in continuation with the previous session, that is communication and distributed system, we have done with the three types of communication. Now we will be moving to the last two, that are RPC and RMI, right? So RPC first, it is remote procedural call. So where it is one of the protocol that is responsible to send a request from the client side and to receive the result of that particular request from the server and to the client side. And this is located in n number of computers throughout the network. And by using this call, by using this procedural call, a function can be called from one machine and can be executed in the another machine and can get the result to the first machine. So the name itself is saying that a procedural call. So this is a procedural call. It's nothing but a function call or subroutine call we can call. This will be at the client side to execute a number of procedures with one call from one machine, and we can execute in any other machine. And here it includes majorly 5 elements. So the elements which we can see here are the client stub, RPC runtime, server stub, and the server. So here the name stub indicates that it's a small piece of code which is responsible for converting parameters accordingly with the client and accordingly with the server. So here the conversion is nothing but we will be packing the request. We will be unpacking the result. Okay. So this is a major element portion which we have to discuss in RPC. Now, if we can see the diagram here, what is the principle of RPC between the client and server program? You can see here. Client will be sending one request. So that request is nothing but I want a procedure from so-and-so system or from so-and-so server. So call remote procedure here. So that is what the remote procedural call. Now server will be alerted and it will be calling that procedure and for processing that procedure and getting the result of that procedure and replying the result back to the client. So whoever called that procedure will be getting that result back to them. So that is what the client server stub functionality in the RPC. So let us see what is the step-by-step procedure here. So coming to the client. So first of all, the client we have in as one of the elements. So the client is nothing but any user who is initiating RPC. Any user who is requesting for a procedural call is nothing but a client in RPC. Now, client will be perfectly calling a normal call like it's a procedural call. Now, immediately the procedural call will be awakened with the client stub. So, what is client stub? It will be taking the request of the client and it will be providing one receipt of a request and it will be packing all the requirements into one message and it will be stamping with that and it will be sending to the RPC runtime. Now RPC runtime will handle that message and will be a mediator between the client and the server. The client will be there, client stub, and in between we have RPC runtime, which is the communication between the client and the server. Now, from the client, RPC runtime will be providing that packed request to the server. Now, immediately the server will be awakened with the server stub. So, server stub will be taking that request and unpacking the request and seeing what is there, what are the requirements the client needs for that. So immediately after analyzing all the requirements and the request from the client, the server will be processing and giving the result which is in the packed format again and sent to RPC runtime back. So from the RPC runtime, it will be reaching from server to the client back. The result of the procedure will be sent to the client back. Okay. So here the server is nothing but the a portion which executes the procedure which the client has been requested and printing the result back to the client through the server stub, right? So this is the step which you can see here. See, the client machine is there. Client is about to call a request or a procedure. Now we will client stub will be packing the requirements of so and so request and sending this to the RPC runtime. Now RPC runtime from the client machine will be sending this packet to the server machine. So server machine RPC runtime will receive that and server stub will unpack and see what is the requirement of the client, and then the server will be executing that procedure and returning the result to the server stub. So server stub will pack the result and send to the RPC runtime. From RPC runtime, so RPC runtime has a capacity to move from server to client. So immediately from server to client, the result packet will be sent to the RPC of client. So from here, client stub will take that and unpack the result, and the final result will be printed on the client machine. So this is a procedure which takes place in the steps of RPC, right? So that is what this is a real-time one. We are calling an add functionality. So what is the add functionality? We are patching with the client stub here. So what is that? A method procedure is add and two variables are there. I mean the parameters I and j. So with that through RPC runtime, so we'll be entering into the server stub. So server stub will unpack that and server will be executing the add method and the result will be sent back as it is to the client. Right? So this is one of the example. Now implementation part of RTC. So RPC. So this is nothing but we will be having two types of protocols: connection oriented and connectionless. In the connection oriented, the only thing is the connection will be strong, but always the connection may be strong sometimes, and when we lose that LAN connection, so everything collapse. I mean the performance will be lost. The only advantage we have in the connection oriented is nothing but the both client and server will be connected strongly and the communication will be very easy. In the connectionless, as this is a user datagram protocol, so Unix system will be working very well in this. So, but compared to the connection oriented performance, connectionless performance will be always lesser. But the packet and message and identification will be somewhat an issue here because it's connectionless, right? And reading 64K file in single 64K RPC is mostly more efficient than reading it 64 1K RPCs. So that indicates that single RPC combination of many bits is easy than multiple RPC bits. Okay, so this is connectionless means so somewhere the data packets may lose. So for that reason, that is one of the issue we are erasing over there. Coming to the advantages and disadvantages. Advantages are nothing but it is a process and connection oriented is possible, thread oriented is possible, and all the procedure which is taking place from the calling of the procedure to the printing of the result, everything will be hidden from the user. Okay, and every every procedure can be changed or redeveloped, rewritten with a minimum cost over here. And this is totally performed in the distributed level and also possible in the local environment also. And RPC will improve the efficiency of many protocol layers. Coming to the disadvantages, the only disadvantage is nothing but this is not a standard. We can't go with this standard every time. This is one of the concept we have in distributed systems. So thus this is not as much as flexible than many other softwares which are inbuilt like a standard. Okay. So and utilization of RPC will take a lot of cost also. Now next one is the RMI. See, RMI is very simple compared to RPC. RMI is a mechanism to create with the applications in Java with a method invocation. Right. So method invocation, as we are saying about Java, the object invocations are very, very important here. We'll be having with JVM client and JVM server. So both JVM client and server will be having the stubs. So client stub is called client object stub is called as a stub, and server side we call it as a object skeleton. Right? At client, the connection remote invocations will be possible with the client side, that is called as a stub. And the receiver and the server side, it will be possible with a skeleton. The name is given as a skeleton. In RPC, we call it client stub and the server stub. In RMI, we call them as a stub and skeleton. Right. So RMI system layer will be having three. First one is a stub or skeleton. Second one is remote reference, and third one is a transport layer. So in the transport layer, through transport layer itself, we'll be starting our communication. I mean, from the client side, we will start at the application layer from the JVM, and then we'll be ending at the transport. And in the server side, we'll start from transport layer to the JVM. So here stub is nothing but we'll be seeing that this at the client side. So when we are going to connect to the object of client and server, so object of client will be called as a stub invocation. So from this object, we'll be connecting to the server object, that is a skeleton over there. So the steps which we are going to follow are at the client side, we have to initialize the JVM, and we have to call a method invocation. I mean, the invoke method means calling a method through an object. Now, object is ready with the Marshall means packing again with all the parameters, and the client will be waiting for the result. Okay. Now, at the skeleton side, it will be taking the data and it will be processing the method invocation, and it will be printing the result and pack that back to the receiver, the client. Now, client will, the fourth point, the client will unmarshal the return result, and it will see the output of that particular method invocation. So these are about stub and skeleton in RMI. So the main goal of this is to preserve safety, and application communication will be possible, and distributed garbage collection is possible here. And as we are dealing with the objects, it will be good enough to utilize than RPC, right? So if you have any doubts in this, please be free to contact anytime in the college or through comments. Thank you.